Assalamualaikum and good day everyone. My name is BINTI RAZALI from Faculty of Health Science UKM. So I'm going to present our group study entitled Curcumin Piperidone Derivatives Induce Anti-Proliferative and Anti-Migratory Effects in alienating Human Glioblastoma Cells. In the recent years, curcumin has gained a great attention as it exhibits numerous biological activities such as anti-cancer, antioxidant, antimicrobial, neuroprotective, antifungal, and anti-inflammatory. However, preclinical and animal studies have shown that this compound has relatively poor bioavailability, rendering it as a poor drug candidate. The poor bioavailability is mainly contributed by the poor absorption as well as rapid metabolism. These problems have prompted researchers to look for other alternatives such as attempting for novel drug delivery systems and designing new synthetic curcumin derivative with modified analogues. So our group has synthesized new curcumin analogues that are formulated with piperidone derivatives, namely FLDP5 and FLDP8, with purpose to overcome the drawbacks of curcumin. In this study, we investigated the mechanism of toxicity of these compounds in alienating human glioblastoma cells, particularly on the mechanism that would show the anti-cancer properties of this compound, and specifically on the anti-proliferative and also anti-migration effects. So why this research is important? So the cell that we are using throughout this study is originated from glioblastoma, and glioblastoma is a grade 4 astrocytoma and is the most common and aggressive malignant primary brain tumor in humans. Moreover, glioblastoma patients have poor prognosis whereby most of the patients hardly survive for more than 1 year. Furthermore, the frontline chemotherapy treatment of glioblastoma, which is temozolomide, shows resistance in glioblastoma cells, including alienating via the upregulation of multitransferase enzyme and deficiency in mismatch repair mechanism. Lastly, we would like to investigate the potential of the new novel compounds due to the limitation of curcumin having a poor bioavailability owing to its poor absorption across the gut, limited tissue distribution, and rapid metabolism. The determination of anti-proliferative effects of this compound were investigated throughout cytotoxic effects and cell cycle arrest. For cytotoxic effect, we carry out 4 different tests, which is for cell viability, for mode of cell death, the involvement of reactive oxygen species, and also DNA damage. For cell cycle arrest, we carry out the analysis of cell cycle using the piRNA staining. The MTT assay, which is for cell viability testing, has revealed that these analogues are able to induce cytotoxicity in alienating human glioblastoma cells in dose-dependent manner following 24-hour treatment with higher toxicity compared to curcumin. The IC50 values of the analogues were 2.4 micromolar and 4 micromolar respectively, which were more potent compared to curcumin with IC50 of 31 micromolar. Then we proceeded with flow cytometry assessment using an simplified CPI in order to determine the mode of cell death of these analogues. The mode of cell death assessment results show that these curcumin analogues, as well as curcumin, induce cytotoxicity through apoptosis in alienating human glioblastoma cells in concentration-dependent manner after 24-hour treatment. Then we proceeded with DHE and DCFHDA staining in order to investigate the involvement of reactive oxygen species, and our results have shown that curcumin analogues are able to induce the reactive oxygen species, specifically superoxide anion and hydrogen peroxide, and the increase in reactive oxygen species confirm the involvement of oxidative stress in inducing the cell death in alienating cells. Alkaline comic assay were carried out in order to investigate the damage of DNA induced by these compounds, and our results demonstrated that these analogues are able to significantly induce DNA damage in alienating cells in time-dependent manner. Severe damage were observed at 6-hour time point treatment, suggested due to the presence of both superoxide anion and hydrogen peroxide at that particular time point. piRNA staining were carried out in order to investigate the ability of this compound in inhibiting the cell cycles. The cell cycle analysis were analyzed using IC25 values for 24-hour treatments, and our results display that these analogs are capable of inducing S-phase cell cycle arrest, which differ from curcumin that inhibited the cell cycle at G2M phase. Then we proceeded to investigate the anti-migration effects of these compounds using scratch wound healing assay and also Bowden chamber transfer assay. For scratch wound healing assay, specifically for cell migration, the treatment with IC50 and IC25 of these analogs show a significant concentration-dependent decrease in the percentage of wound closure. A significant difference could be seen at 48-hour time point treatment, where the untreated group show a full closure of the wound, while the wound still hasn't fully closed in the treatment groups. Then for cell invasion were investigated using Bowden chamber transfer assay, where all the treatment compounds were able to reduce the percentage of relative invasion in the L18 cells in a significant dose-dependent manner compared to the untreated group after 24-hour treatment. So this is the schematic representation of these analogs induce anti-proliferative and anti-migratory effects in L18 human glioblastoma cells. Anti-proliferation effects could be observed through induction of apoptosis and inhibition of cell cycle, while the anti-migration could be observed through the inhibition of migration and invasion. Overall, this study has demonstrated that these analogs are able to exhibit anti-cancer effects with anti-proliferative and anti-migratory properties in glioblastoma with higher potency compared to curcumin. However, further investigation into the underlying mechanism that cause the cell death should be carried out, as it could greatly enhance the understanding of the anti-cancer role of these compounds. That's all from me. Thank you for listening.